As part of this topic, let's analyze both January 2008 air traffic as well as airport codes datasets that are going to be used for joins. We will use January 2008 air traffic data which have all relevant flight details such as departure, arrival, etc. As part of the analysis, we also might want additional metadata such as city, state, etc. for airports. That information is not there as part of the air traffic data which we are going to use to get relevant flight details. We got this additional metadata as part of airport codes dataset. Let's review both January 2008 air traffic data as well as airport codes dataset so that we understand the data better before getting into joins. This cell will take care of creating the Spark session object for us. The Spark session object is nothing but Spark. We have ran this entire notebook already. I will be going through the output to make sure that you understand details about analyzing the data that is relevant to air traffic as well as airport codes. Now if I scroll down, you can see that I have set a property called as spark.sql.shuffle partitions to 2. It actually takes care of not using too many resources to join these simple datasets at a later point in time. Make sure you use this when you try to join smaller datasets. Don't use the default value which is nothing but 200. Now we are going to read data from this location into data frame called as air traffic using this piece of code. Spark.read.parquet of this path will take care of reading the parquet file format data in this location into the data frame called as air traffic. You can review the schema of this air traffic. You have all these fields such as year, month, day of week, departure time, years, departure time, so on and so forth. However, it doesn't contain any information related to city, state, etc. It only have airport codes as part of origin and destination. Origin means the airport from which the flight is departed. Destination is nothing but the airport at which flight is arrived. You can also preview the data here by saying dataframe.show. You can go to the details if you are interested. We have data for almost all the fields in this data frame. Now, if you scroll down further, we'll be using another dataset to get details about airports. The details include information such as state, city, etc. for a given airport code. Let's go to the details so that we understand the data related to airport codes as well. This is the path in which we have the airport codes files. We have already ran hdfs dfs-ls command on this location as part of the previous topic. If you want to rerun again, either you can add another cell and use exclamation mark or percentage sh to run hdfs dfs-ls, or you can also use terminal. As part of the terminal, you should be able to run this command to validate the location. The location have a file called as airport codes na.txt. You can see the details here. We are not sure how the data is delimited. To understand how the data is delimited and also what all fields we have, we can actually use spark.read.text and pass this path, and we should be able to see the output. The reason why I'm using a truncate equal to false is so that we should be able to see the complete record details. You can see that the data contain header. This is nothing but header for this dataset, and also you can see 19 additional records which contain city, state, country, and then IATA. IATA is nothing but airport code. If you look at the delimiter, it is using tab character as delimiter here. It might not be obvious, but I have already did some analysis and I have determined that it is tab character. If you are not sure, you can actually read the data using tab character first and see if it is actually presenting the data as per our expectation. If not, we have to deep dive further and make sure that we understood the delimiting character. That being said, once we go through this data, we have determined that data is tab separated. There is header for the dataset, and also dataset have 4 fields: country, state, city, and IATA. Using this information, we should be able to read the data from this folder into a data frame where the data frame will contain 4 fields. For that, between spark.read. and CSV, we have to use these options. We have to set separator to tab, header as true, info schema as true. The reason why we are saying header as true is because we have header for our data. These can be used as column names. Info schema will make sure that the data types are determined based upon the values we have in our data. So it will take care of using appropriate data types when data frame is being created. You should be able to preview the data once the data frame is created by using show like this, and you can see the output. The data is published as per our expectation. There are no issues related to any data quality here, which means tab is the right delimiter for our dataset, and also header is determined appropriately. You can also preview the schema by using a print schema like this. You can see that it have 4 fields: city, state, country, and IATA. The data types are nothing but strings only. All these fields are of type string only. Now, if you want to get the count of records, we have 526 records in this data frame. We need to ensure that there is no data quality issues in our data. For that reason, I am actually getting the count of unique records and see if it is same as total count. Talk about unique records, I am only talking about airport codes. Airport codes are part of IATA field. When I say airport codes dot select of IATA dot distinct dot count, we are getting 524 here, which means there are a couple of duplicates as part of our data frame. If they are not equal, we need to analyze the data and identify those IATA codes which are repeated more than once, and we might have to discard those which are not relevant for further analysis. Now, using this piece of code, I am actually getting the airport codes which have count greater than 1. Only one airport actually repeated thrice. The airport code is nothing but big, and it is repeated twice. You can see the output here. Now you should be able to filter for a big like this, and you should be able to review the data. When it comes to city and state, they are represented differently using this airport code. Out of these three, we are interested only in one. We'll be considering this one, and we'll be discarding these two. For that reason, I am using this filter not state equal to Hawaii and IATA equal to big, which means these two will be discarded. You can see the output here. This will actually return only 524 airport codes which are unique in nature. We have performed another task to analyze airport codes data further. It is nothing but get number of airports for each state in the US. Also, we want to sort the data in descending order by count. This is the location under which we have the file. We have defined a variable by name airport codes path. Using this piece of code, we are able to create the data frame. This data frame will contain all the airports that are there as part of airport codes dataset. However, we are interested only in US, and also we want to eliminate duplicates related to BIG airport, and hence we have this additional filter condition where data is filtered for USA, and also discard those two additional records which are related to BIG airport. So this airport codes will contain only US related unique airports. You can see the count here. We have 443 airports in US. Using this piece of code, we are able to get the count of airports per state. Using airport codes data frame, we are able to group by country and state. Once the data is grouped by country and state, we are able to use the add function to invoke count and get the airport count. We are providing alias for airport count as IATA count. Once the alias is defined, we should be able to use it as part of order by. We can use DESC function like this to sort the data in descending order by count. Airport count by state will contain the data related to count for each state. That too in descending order by count. You should be able to validate by saying airport count by state dot show of 51. You can see the output here. California is the top state with 29 airports, followed by Texas with 26, so and so forth. New York have 18, Michigan have 18, Florida have 18. I am not sure about MT. PA is Pennsylvania, it have 13. Illinois have 12, so and so forth. If you want to get the count of this data frame, you should be able to say data frame count like this, and you can see the output here. We have 51 states count here. This is how you should be able to analyze the data before you actually perform the tasks using this dataset. It's very, very important for you to understand the data characteristics before you get into the complex tasks solving your problem statements related to your application requirements.